I think I'm on. Okay, we get started. I was not warned. Hi, everyone. Thanks for coming to this talk today. Thanks for staying. How many of you are part of the Azure IoT team or are here to support us? Okay, thank you. So today you're going to hear about the Azure IoT platform and security innovations. What's new? And what we wanted to do actually is to put some focus on data insights for IoT and security. I'm actually the MC, basically. I'm going to introduce stuff, but your star speakers will be Eustace and Chandrika. We're going to come up just after. What I want to do before jumping into the presentation is give you some context on how we are approaching IoT and how we are considering the work we're doing to serve our customers. And the way we're actually approaching that, for some of you might have seen that slide, is we consider that IoT is enabling a feedback loop, a digital feedback loop that will allow our customers to digitally transform their business by optimizing operations, transforming products, empowering their employees, and engaging customers. And to do that, actually, they need to have data from the devices, the things, data from people, data from the places and spaces that they're in, and they need to harness that data and extract insights, and then take action, right? And why we think it's all about data? It's definitely all about data, right? About securing the data, ingesting the data, analyzing the data. And one of the reasons why we think IoT is key component to that is when you look at the number of devices that we expect to have connected. So that number is funny because it changes all the time, going up exponentially. So now, the latest number is that by 2025, we're expecting to have 80 billion things connected. And these 80 billion things will generate 180 zettabytes of data per year. Anyone knows, and the one who answers gets an MX chip board. Anyone knows how many zeros is a zettabyte? No, it's not 18. 50. No. 21? 21 was down there? I'm going to kill someone. There you go. So a lot of data. That's more than what the internet has generated since it exists. And that's going to be per year. And that's going to be generated by IoT devices only, right? So that's kind of important. So let's talk about what we're doing to help our customers, to help you guys as well implement IoT solutions. And to do that, I want to introduce at a high level what an IoT application is about. An IoT application is about things, right? Easy. It's about extracting data from these things and getting insights from that data, understanding the data, analyzing the data. And then, even more important than the actual insights is the actions you're going to take. If you have valid and important information about data coming from things and sensors and people and others, well, if you don't take action on that insights, it's kind of useless. So it's super important to understand there's that actions side of things. So it seems pretty simple, right? Things, insights, actions. Actually, it's a bit more complicated than that. IoT solutions are complicated. You need to think about a lot of things. It goes to device recovery, device lifecycle, device updates, the protocols you're going to use to connect these devices, the cloud-to-device commands, who's controlling who's connecting where, security across the board, and Eustace will detail that. The strategies for storing data and analyzing the data. The data ownership as well, the location of the devices and of the data, ownership of that data as well. All of these things are super complex and are part of an IoT solution. And that's why IoT actually needs to be simplified. What we're trying to do is to simplify IoT. And this is our motto. Someone say that. I have a second MX chip device. If you can tell me who said that, you'll get the board. I'll let you read. I cannot read that. It's too long. Nope. Yes, Einstein. Einstein said that, and what really he meant is something in the lines of everything should be made as simple as possible, but not simpler. I'll leave it here for you. So we want to make IoT simple as possible, but not simpler, right? So we need to provide the right set of tools for empowering our customers, our partners, to build IoT solutions and be successful. So let me actually tell you a bit more about how we are trying to simplify things by going more in-depth into an architecture of an IoT solution. I'm not talking about IoT Central here. IoT Central is the ultimate simplification of IoT. One-click deploy and you have an IoT solution, just works, has everything in there. What I want to talk about is what's under the hoods, what's under an IoT Central solution that you might want to go and play with and develop your own solutions based out, right? So the various parts of an IoT application, and that's true for IoT Central as well, it's just you need to understand how that works underneath. You need to have devices. You need to connect the devices. So you need to think about having a cloud gateway that will allow you to authenticate and to manage these devices. You need to think about how you're going to store the data of these devices. You're going to eventually want to do some live stream processing of that data to extract information immediately on that data as it just arrived. You will want to integrate with your line of business application. This is where you're going to take action. You detect that something will go wrong in the future in your factory floor. You want to create a ticket for maintenance team to go maintain that machine, right? So you want to take action integrating into your line of business application. You also want to have some tooling for visualizing that IoT data and reporting to the users, but also controlling and configuring the devices back through the cloud gateway. You need to also think about, things more complicated, such as some devices are less simple than others. They need to eventually run some of the workload you've been developing in the cloud at the edge. We have some technologies for that, and I'll talk about them in a second. But you need to think about the various types of devices that eventually are behind a gateway. They're actually clusterized eventually. You need to think about how you're going to provision these devices at scale. Configuring one device that you buy on whatever maker website and playing with it is one thing. You can actually hard code the credentials for connecting and so forth. When you do that at a production IoT scale, you need to think about the technology that will help you provision, re-provision, manage the life cycle of your devices. You need to think about data transformation. Data, as we'll talk about, actually takes various shapes, various formats. You need to actually be able to transform the data on the flow. You need to think about the various strategies for storing the data. How fast do you want to access the data? Do you want to store it for long-term analytics and later analytics on some cheaper storage technology, or do you want to have instant access to that data? You want to do advanced analytics, machine learning, and others. You want to also do user management. All these things are complex to do, and these are all the parts that actually we are providing as a platform. And this is not even mentioning the things that are what I call the cross-cutting needs, security across the board, end-to-end, and Eustace will talk at length about that. Deployment, how do you deploy a solution that you create for a customer for another one? How do you deploy across geographies and so on? Last but not least, high availability and disaster recovery. You're serving an application for customers, whether they're consumer or businesses. You have to maintain that application up and live, especially if that application is about detecting some failure and improving processes. Let's talk about tech real quick, and then we'll dive into the various things. Here is what we have within the Azure IoT team and more in Azure to address these various bits and pieces of an IoT solution. IoT Hub is our cloud gateway for devices. IoT Hub DPS is a device provisioning service that pairs with IoT Hub for provisioning devices at scale. Think of it as the concierge for devices. Devices come up, knock at the door, they're recognized, they're assigned to an IoT Hub, they get the credentials, and then boom, they connect to your application and it can be used. For edge devices are smarter gateways where you want to eventually run some machine learning algorithms and so on. We have something called Azure IoT Edge. We have a session, I don't remember, Archman, if it happened already or not, but there's a session about IoT Edge. Tomorrow at noon, Azure IoT Edge, where Archman and team actually will present. Azure Stream Analytics is another service in Azure that we are leveraging as the IoT team that is actually designed for doing real-time analytics on data. TimeSeries Insight, Cosmos DB, Azure Blob, and Data Lake are all the technologies you will have to think about using for your storage, whether it's for a warm scenario, cold path scenario. Chandrika actually will talk at length about TSI in a minute. When it comes to data transformation, Azure Function is a great tool. TSI can do some data transformation also for normalizing data and making sure everything looks as you expect after. Visualization, websites, web technologies, but also services such as TimeSeries Insights or Azure Maps allow you to visualize the data in context, inject data from other services and other data sources, and allow you to have some better visualization, some better information for your users. When it comes to business integration, Logic Apps is a good option. Already has tons of connectors for you to directly trigger flows into your line of business applications. On the advanced analytics, Azure Machine Learning, Databricks, whatever you want to analyze data at scale, at an IoT scale. And Azure Active Directory for you to manage users. All of these are the Azure platform services that will allow you to build an IoT solution end-to-end. Right? We have tons of tools for you to aggregate these services and make your life easier. You don't have to think about these plumbing. It's there by default. Even better, you get Azure as a platform for your IoT application to manage the role-based access control. So your users, who can access what in your application. You also benefit from all the PaaS, AKS, Service Fabric infrastructure that Azure offers for you to deploy your Azure IoT applications here and there. So this is an IoT application. This is a lot of things to ingest and think about. What we want today is to focus on the middle part, which is the insights. Focusing on IoT data is key because, as I mentioned already, lots of data, you extract the insights, and then you take action. This is where the value is. This is where you transform the business. It's out of that insight you extract from the data, from the IoT devices, things, spaces, and people. But that data actually is what I call multidimensional. Different devices produce different types of data in different formats. So you need to actually make sense of all of that. And that data makes sense in a specific context very often. Right? The temperature that is actually measured in this room might not mean the same thing as the same temperature in a fridge. Right? The value itself has a meaning because we know it's in a fridge or in a conference room. Right? So that's one thing, which is you need to think about the location of the device as one of your context data points. Another one is time. Time is key, right? The temperature that you have here right now doesn't mean the same thing as the temperature overnight, where you actually want the room to be cooler and save energy, or actually hotter in the summer. But depending on time in the day, that data doesn't have the same meaning. Is it too hot or not? Depends. Right? So you need to think about location-based data and time-based data as your two of the many dimensions, but that are key and important for you to manage, and that are not trivial to manage and to understand and to deal with. So the first one is the location-based data. And I'm going to actually fly through Azure Maps because I'm not the expert here, and we have people on the booth that can talk at length about Azure Maps, which is a platform that gives you a set of APIs for managing in real time the integration of your things data with other third-party services or in the world of mobility. Think of it as locating devices, integrating with data from other services, and so forth. Maps offers mapping, obviously, to render maps, and you'll see an example of one of them in a second. Offers SDKs for you to build apps for the web and for Android that will allow you to integrate a map into your IoT application that will put your device's data in context, in location. You will have APIs for doing routing. So if you do fleet management, right, you know where the devices are, actually the data is coming from by having a GPS pinpoint, and you can integrate that into your app, and you can decide to route that truck or whatever, depending on the information, which is actually the actual routes that these trucks, whatever, can go on. Then you also will be able to do search. Everything that you would expect from a mapping infrastructure. Traffic, mobility, time zones, geolocation, spatial operations. Very interesting, actually, spatial operation. Think of it as a few lines of code to create a geofence, and then trigger an alert when a device is actually coming out of a zone that you define in your mapping application, right? And also, the ability to store that map data into your own application on Azure, because Azure Maps is designed for enterprise and is something that comes as an instance of the service in your Azure subscription. And you can totally partition your own data or your customer's data into the data center of your choice and keep it there and not share with the rest of the world through some of the generic mapping services out there. We did some announcements. The key one that we did during build was a partnership with MoveIt that allows to have in Azure Maps mobility services data, such as transit information, such as routing using biking or scooter or whatever parameters. You can then imagine tons of scenarios that are related to public transportation or to various ways of going around. And if you correlate that with the rest of the information that we got from other partners, you can imagine scenarios where, hey, how about I'm transporting something highly flammable on my scooter, and what route should I take? Because I'm super tall and I'm going to go under a bridge, and eventually I could use the bus there, right? Don't ask me to create IoT apps. That would be crazy. But mobility services is now available as a preview. Another announcement we're making is spatial operations being generally available for those who already are using Azure Maps. Anyone? Anyone in the team? No, in the room? No? Well, when you're going to be using Azure Maps, you'll realize that spatial operations is already available for production, where you can actually consider very advanced application that use, in particular, things such as geofencing, closest points finding, and things like that. I think I'm already running over time, so I'm going to go on to that last slide before giving it to Chandrika. SDK's update, we actually brought in light gray map style, support for drawing tools, spatial map features, drawing tools modules. This is an enhancement to the existing and already super rich SDKs that we have for the web. Same thing for Android. We're bringing new features in there. So go out, test out Azure Maps. We have a link actually for demos that I'm going to be happy to share towards the end, where actually all the samples of Azure Maps are displayed into a web page, and you can navigate the code and test the samples. It's going to be way more efficient if you guys actually, as a homework, you go to Azure Samples and play around with it. So we talked about the location-based data. I want to now pass it over to Chandrika to talk about the time-based data.
Thank you, Olivier. Hi, folks. My name is Chandrika Shankarnarayan, and I lead the efforts for IoT TimeSeries analytics, and we'll talk about that in a little bit. Before I get to the topic itself, I want to show of hands, how many of you folks in this room build IoT solutions? That's a lot of you. How many of you folks build IoT solutions using Azure services, specifically Azure IoT technologies? That's more than half the room. And the last question, I promise. How many of you folks are using Azure TimeSeries Insights today? That's a very small handful. OK, that's good to know. So I wanted to sort of understand the context of how much you folks know about Azure TimeSeries Insights and how much ground I need to cover. I only have now, thanks to Olivier, about maybe 20 less minutes. Each of these topics we're covering in this session deserve a full hour. There's a lot to cover. We're going to do our very best to cover as much as we can. And as Olivier promised, we have booths. Please go visit them. There's plenty of demos, plenty of people from the product team helping as well. So I'll cover as quickly as I can, as much as I can. And we'll leave some room for Q&A in the end. Next one. OK. So along the lines of what Olivier was talking about in terms of IoT data characteristics, I want to stress a little bit more on industrial IoT data characteristics. And this sort of sets the context for what we are trying to do with Azure TimeSeries Insights. IoT data, first and foremost, lacks structural consistency. Most data that comes from IoT devices or things are either unstructured or semi-structured or maybe structured too. So we're dealing with a combination of data that has structural inconsistency rather. So there's a lot of work that needs to be done to normalize this data. And we've learned from usage scenarios that a large portion of this data gets thrown away. Only a fraction gets really used for analytics and insights. So it is super important to get to that data that is useful and normalize that data and consume it for analytics, right? That's the first and foremost thing. Second thing is, as Olivier pointed out, IoT data needs contextualization. And again, this is another thing that we hear from customers all the time. Telemetry data in itself is not very useful. Data coming from sensors needs to be contextualized. You need to see it through the lens of the context that that data is coming from. And in order to do that, you need things like data models. You need to be able to describe the shape of that data and the context of that data. And that telemetry data needs to then be correlated together with the context to be able to give you interesting insights and analytics to drive the operational intelligence you want. The third thing is IoT data is used typically with other data. It's useful not only to look at telemetry data coming from devices, it's useful to correlate that with other data that influence your business decisions when you make business decisions together with that data. For example, in the automotive industry, we talked about maps a lot in the prior section. Geospatial data is very useful in the automotive industry. You combine that with data coming from sensors in order to drive your operational intelligence. In the energy domain, we have customers driving wind farms. They typically rely on weather data, which comes from third-party sources, to be able to correlate weather patterns together with the performance of their devices in the wind farms. So this kind of correlating third-party data sources and data together with telemetry data coming from sensors is a very important aspect of dealing with industrial IoT data. The last but not least very important aspect of industrial IoT data is that many of you folks dealing with industrial IoT are dealing with large volumes of data, and you have historical data archived from years worth, 10, 20 years worth of data. And typically, you go back to that data to do things like predictive analytics, troubleshooting, pattern matching, et cetera. So you need that data to look back and say, 2 years ago, how did this device perform, or how did this thing perform? You want to be able to correlate to that pattern and say, how should I predict the performance of this thing? How do I do forecasting? How do I compare and contrast and drive operational intelligence? So for that reason, you need to have infinite retention. So these are the typical characteristics of industrial IoT data. Now, why am I saying this? There's a very important correlation between what the characteristic of industrial IoT data is and what it is that we're doing with TimeSeries Insights and what are we trying to achieve as far as our vision and our strategy and goal is. And before I get into that, since most of you folks have very little knowledge of what we're offering in this space, I want to first touch on what is it that we're offering today. Azure TimeSeries Insights is a fully managed PaaS solution, end-to-end platform as a service solution to ingest, process, store, and query data. And I'll stop at that. And that's what we're doing today. We have an in-market solution that allows you to do all of this. Now, you might ask the question, well, what is the difference between this and any other big data analytics solution that you get from Azure, from our Azure cloud? Well, the answer is what follows after. What we're focusing on is highly contextualized, time series optimized IoT scale data. We're a purpose-built solution for industrial IoT analytics. And we'll touch on contextualization and time series optimization over in the next few slides. The second big thing I want to point out is what we're offering is a highly flexible data platform. I almost want to call it an open data platform, but I stopped myself from saying that because there is an industry consortium and there's a standard that open source is driving towards. So it's not so much to say that we're an open source system, but we're a highly flexible data platform that allows for connectivity to a variety of data scenarios and a variety of data services. And again, we'll give some examples down the road. It's ideal for ad hoc exploration. If you don't know the shape of your data and you're asking some very generic questions of the data, it's very ideal for those scenarios. Additionally, what we're adding as an industrial IoT strength analytics platform is asset-based operational intelligence. And we'll show some demos as well. It's tailored towards this. It's a fit-for-purpose industrial IoT analytics solution as a result. So let's get into the actual, let me build this out. Why is it that we call ourselves Industrial IoT Data Analytics Platform? First and foremost, for those of you that do IoT analytics, you'll know that a lot of times you're doing ad hoc analysis over data, which means that you don't know the shape of the data that is coming from the assets and devices. So you're asking simple questions like, how often did a given event occur? Or can I visually spot an anomaly that's occurring based on the patterns I'm looking at? The second main scenario that we see customers doing is operational analysis over the data, where you're explicitly modeling the data. This means that you can ask some intelligent questions of the data. You can query for events based on device ID and a time range, or you can query for all daily results of a KPI across the entire installation, or maybe a single installation. So you can do cross queries across devices, within an installation, across installations. These are kinds of things that help you drive operational intelligence and drive process efficiency within your IoT solution. So what we're building with TSI is time series insights, short TSI. I will use TSI a lot in this session to be short. What we're building is capabilities for doing ad hoc exploration, but also to be able to drive operational intelligence for where you know the shape of your data and you're explicitly modeling your data. So that's the reason we consider ourselves a specialized solution for industrial IoT data analytics. So to quickly jump into the architecture, like with any other big data analytics capabilities, you need to collect data, you need to process data, you need to store and analyze data. That is standard practice. Should not be surprising for you. What we're doing it to specifically address industrial IoT is obviously we have to consume data through a cloud gateway, which should be IoT Hub or Event Hub in our case. We will also allow for batch uploading data. If you have data on premises that's multi-year worth, we'll allow you to batch upload data into our cloud data lake. We do some level of processing, as Olivia pointed out. We do flattening of your JSON and do type updates, etc., and be able to then route your data to warm or cold. We'll build time-based, retention-based routing capabilities to store data in your warm storage or your cold storage. I mentioned flexible data platform. I want to touch on it. What we allow you to do is you bring your own Azure storage account. So you own that storage account. You provision that together with TimeSeries Insights. So at the end of the day, you're the owner of your data. You're pushing your telemetry data to your storage account. What we do is we do work on your telemetry data in your storage account to be able to index and partition that data such that it's available for query immediately. We hear a lot of customers say, I've already stored my data in a cloud data lake. I don't know what to do with it yet. I want to make it available for analytics. This is exactly what TimeSeries Insights is useful for. So when you bring your storage account, you push your telemetry data, we work on your data, and we keep your data, prep your data to be ready for analytics. Another big part of this is contextualization. So we support a time series model capability that allows you to model your hierarchies, your types, and your variables and your instances. And that allows you to, if you already have a digital twin or asset framework that you're working with, or a context you're working with, you can map that directly into its analytical twin, if you will, such that you can now add context to the telemetry that's coming through from your devices and sensors. What we have is a distributed query engine that can then query both warm and cold and give you sort of signal processing semantics to be able to ask device-based queries, like device-based analysis. You could be doing simple analysis that are just analytics, or you may want to do very complex operational intelligence where you're going across devices, we might be going across installations, such that you can drive operational intelligence by correlating all sorts of interesting data. And we also have a visualization, as was mentioned in the reference architecture. We have our own app. We call it the TimeSeries Insights Explorer that allows you to do very rich visualizations. We also provide a JavaScript control library that allows you, as a customer, if you want to build your own custom visualization, to take our library of controls and go build your own custom application. And talking about the openness and flexibility of our data platform, we store our data as data that's coming through, telemetry that's streaming through in an open source file format, which is Apache Parquet. What that allows you to do is to then take that data that you own in your storage account in an open source format to go push it to another system, another data service to do other advanced analytics. We have several customers who want to be able to take data to HDI or Databricks or AML or even third-party data services, so they can do some predictive maintenance type work, do your modeling and bring it back to drive forecasting and scenarios that you've done modeling over. So that's a good open system that allows you to derive a lot of operational efficiency as you push data into the TimeSeries Insights data lake. So very quickly, I touched on this already. I'm going to skim through this. TimeSeries optimized because we store data. We first-class TimeSeries as a first-class object inside of our system, which means that when you query, you're not actually having to go look at multiple tables and do indexing and partitioning yourself. We've already pre-done it. We've stored TimeSeries ID, TimeSeries as a first-class citizen. And therefore, you're querying by TimeSeries, which means you're querying by your device or your asset, and you're getting first-class experience to do analytics and operational intelligence. And this is done over cold and warm, as I said. We're providing rich contextualization. Your queries are highly scalable, therefore, and highly performant because of all the repartitioning work we do on that data. Advanced analytics we talked about. Because of that openness of that data platform, you can take data anywhere you want, and you can bring your data back into the same data lake. We talked about user experience. We sit inside of the Azure IoT organization, which gives us a very big incentive to make our integration with Azure IoT Hub first class. So we have very good integration with IoT Hub. We leverage IoT Hub. You probably heard at the conference the announcement of plug-and-play model, device model. So we're going to be fully integrated into device models such that if you have a plug-and-play device that has a device model schema, we talked about, I think, DTDL was announced in Britain's session earlier yesterday. DTDL will be essentially what we call TimeSeries model will sort of be fully incorporated into DTDL such that you define your schema once for your device model, for your entity twin, and for your analytics, such that you're able to, you may hook up your device through IoT Hub into TSI, and TSI automatically gleans that model. You shouldn't have to reauthor the model inside of TSI. So that's the idea. Your analytics light up the moment you have PNP-enabled devices. And the last but not least, very important one is that we have what we have for a business model is a consumption-based model, which means you pay as you go for what you use. So we have split out the meters such that you pay for how much you ingress, you pay for how much you query, and you pay for how much you store. So based on where you store the data, warm or cold, you're probably paying more in warm because it's a RAM and SSD-based warm store, but you're not paying for querying over warm. On the other hand, for cold, you're not paying anything. It's Azure storage-based, very little. Not paying anything. You are paying, but very little. And your queries, you're paying per query over cold, right? So there's a trade-off. Customers say, hey, I want to be able to do quick analytics over short time span data, and I'm willing to pay the price for storage, but I want lots and lots and lots of analytics. On the other hand, I want to archive 5 years or 10 years worth of data, which I'm going to query very rarely for specific scenarios, so I'm willing to pay per query over cold. So that's kind of the idea for where we went with the business model. This is a very quick overview, but I think what I'm going to do is skip this in the interest of the demo, simply to show similar reference architecture that Olivier showed, to show the path from ingestion to processing to storage to analytics. Let me actually dive into the demo quickly. So here's Azure TimeSeries Insights as we released it at as a public preview product at the beginning of December last year. So what I'm showing here is on the left-hand side, you'll see what I talked about in the TimeSeries model as hierarchy. So we talked about context a lot. So you'll see a bunch of context on the left-hand side. So we are using a sample environment here that has a fictitious Contoso organization, and Contoso is managing a fleet of delivery trucks. So they're deployed globally. They have operations in Brazil, Canada, Mexico, and USA. So we kind of modeled your Contoso's context to explore the entire hierarchy of how Contoso might want to manage their fleets. So if I start to open up these hierarchies, I'll start to see the region. The hierarchy looks like it has at the root node, it has a region. It has the AdventureWorks transport system, which is the servicing company, Falcon, which is the manufacturer themselves, and the year the fleet was manufactured, and this is specifically the model. So we've described the hierarchy using a model, and you can visualize that in the TimeSeries Insights Explorer application. What I'm going to do here is I'm going to look at a delivery truck 1008, and I'm going to drop a time series, which is an asset. It's essentially, I'm looking at a device, and it's variable, and I'm plotting that information. What I'm trying to do is, this gives you a lot of flexibility to explore and search, etc. What I'm going to do is try to look for this is showing my last 24 hours, and I'll scan for the last 30 days worth of data. And here's the specific time series. There's very interesting information in here. I can actually change the interval. It's looking at a 2-hour interval. I can actually coarse grain it further and look at a 6-hour or a larger interval space. I can do a few things here in the user experience. I can look at, you can see that I have shadows enabled here. So I'm actually not only looking at is the average information, which shows me the min and max. I'm actually looking at shadows as well. So if I disable shadows, I can actually look at the real data. I may want to also, there's probably here some interesting data that I'm looking at. There are spikes here. I may want to zoom in and look at what's happening specifically with this particular time series. I can also add some dots to show you the exact spots for sort of like simulating actual discrete events themselves, and to be able to see the exact maximum and the minimum for that particular time series. What I want to show is a few more things in here. Before I get to the model, let me actually add another. Am I running out of time? Not you. Okay.
Well, you do have 4 minutes left.
Okay. All right, quickly, we looked at a specific time series. We looked at a way to do analytics over a specific time series. What I want to also show you is cross-correlation of interesting device or different interesting variables coming from either a single installation, or it could also be coming from multiple installations. So here I'm looking at a single installation. In this case, AdventureWorks Falcon. I'm looking at 2019, and specifically this, and a delivery truck. So you can see that my user experience is showing me specific time series. These are devices themselves, delivery truck 1024. And I'm looking at two separate measures, or variables as we call them, average coolant and average temperature. So they're plotted against each other, against the same time span, but I can start to look at correlation of what's happening when cooling goes up. Is my temperature going down, or how are they interacting with each other? So I can also, if I see an anomaly, I can actually zoom into this and understand what exactly is going on. I can do some of the same UI operations I was talking about, which is, I can remove the shadows, add discrete variables. Many of these things are supported by the engine. Some of these are UI-specific features. We're obviously making sure that our engine moves along as fast as we can to support the capabilities that we need. And then I can do other things, like if I want to share the query if I have multiple users in my organization, I want to share this query with other users, I can share the query. Obviously, I can save a query for later use if I want to come back. And if I'm doing very, very detailed analysis, I may want to save this and come back later for usage as well. The thing that I want to stop quickly and show you is the model itself. So we talked about the hierarchy. This is the hierarchy we looked at in the analytics user experience itself. Here's how I've modeled it. So when you model time series model itself, it's really a JSON schema. You can upload the schema directly into TSI, Time Series Insights. You can also author this inside of the tool. We don't expect customers if you're dealing with millions of devices, you're not really sitting here and authoring millions of instances, right? You're really authoring the JSON outside. You're uploading the JSON into Time Series Insights. You may come here to edit or correct or course correct. You may be adding a variable, removing a variable, that kind of stuff. That kind of authoring is very, very useful to do right here inside of the user experience. I can certainly go and add I can certainly add new hierarchies. I can select an existing hierarchy and edit the hierarchy as well if I want to add more levels, etc. Your types are really your named calculations, right? So you can define variables for each of those. We give you a default type, and we have the ability to add more variables to it as well. Your instances themselves are the actual time series, and as you can see, there's a number of different things that come with these instances. You can start to define very, very interesting instance fields that allow you to bring your reference data essentially, and so that you can start to do very, very interesting correlations within time series or across time series as well. What I'm going to go back here in the interest of time, I can also save, and I'm going to skip saving all of this stuff. We talked about open data platform and data connectivity to other data services. I want to quickly show you how we do this. So we are, as part of, and I'll talk about that in the last slide, which talks about roadmap. We want to be able to give customers the ability to not only store data inside of Time Series Insights data lake, but also give you the ability to take that data elsewhere for other stuff you might do. A lot of our customers say, hey, can I take this data and go do predictive analytics outside of Time Series Insights because I have a business investment in, say, Azure Databricks. So we should be able to take that and go take the data out of Time Series Insights and go to Azure Databricks and do your modeling there, bring that model data back into Time Series Insights, and continue to drive analytics. Or you may say, there are customers that come to us and say, hey, I use Power BI heavily in my organization. My business users use Power BI a lot. Wouldn't it be nice to take a few of your time series analytics over into Power BI. So we have many of these data connector work underway right now. So I'll show you very quickly the Power BI POC that we have in the works. So we've built a connector that's still in POC. So if I go to Azure, you'll see TimeSeries Insights connector. This is not publicly available to anyone just yet, but we will make it available fairly soon. We've given it to a few customers to go play with and give us feedback. So you'll see that Azure TimeSeries Insights Preview allows you to pick your data source. What we've done with this is every query that you can experience inside of that's available, every API that's available inside of Azure TimeSeries Insights, whether it's your model, the model itself, which is your hierarchies, your types, etc., or the actual queries, the aggregates and the raw APIs themselves, are available in Power BI through this connector. So you can take that and make those queries available inside of Power BI. So I can say, take my saved query, take my saved query here, or use the custom query that I want to create inside of Power BI to push to my Power BI dashboard. I'm not going to do this right now because it's a slightly longer process. Those of you that have used Power BI know that you have to go through authentication, and it's time consuming. So I'm going to quickly show you what we've done here. So this is a Power BI web. We've taken a few of the queries from inside of TimeSeries. You saw me show average speed. You saw me show speed versus temperature, continuous time series. Those are all brought into Power BI. Temperature versus vibration. These are all the correlations that you were doing live over streaming data inside of TimeSeries Insights. We've taken that same APIs and exposed them inside of Power BI. The speed analysis, scatter plotting, which is another big feature that's coming into TimeSeries Insights. You can already start to do that if you get your variables inside of Power BI. The same power that you have in TimeSeries Insights can be obtained inside of Power BI by taking that same data and exposing it through the connector inside of Power BI. We're doing the same effort across many other data connectors. We have a Spark connector that's in POC right now to push data to HDI or Databricks, and we'll be doing more down the road as well. With that, let's just quickly switch to slides, and one last slide here to talk about the TimeSeries Insights roadmap. There's a lot coming, so feel free to stop by the booths and ask us questions about each of these line items. There's a lot to go through. We're bringing in warm and cold analytics. What we released in public preview as of December last year is the cold long-term storage with Azure Storage, the open data capability that I talked about, to bring in data and store it and model it and get rich operational insights. What we're adding this summer is the ability to bring warm and cold into a single, oops, did I do that? So, I didn't do that. So Olivier, not nice. One more. Thank you. So bringing warm and cold analytics into a single consumption-based experience, retention-based routing. The plug and play is a very important takeaway for you guys from build. If you're looking to digest plug and play and digital twin concept, please know that this is going to be one single offering with plug and play digital twin device model and time series model as a single unified schema with a single unified modeling language. That's where we're driving towards, to give you the end-to-end IoT solution and platform capability. And everything above the platform will leverage it, including IoT Central, right? There's a ton of updates coming with time series query. We're adding scalar expressions, signal reconstruction, interpolation is a very big scenario for us. Composition with merging and joining, time-weighted average, discrete variables, you saw some examples. We're taking the product to GA, so enterprise readiness is big. A lot of advanced analytics work that's already underway, including anomaly detection, alerting, and that sort of stuff. Lots of updates to the user experience. You saw everything that we do in the engine will get exposed through our app as well. Of course, you're free to use your own application. Our SDK will get updated as we go, so you can take that or you can write your own app. Batch upload we talked about. This is very important because we're taking full-blown industrial IoT analytics as a strategy on, and that means that a lot of our customers are coming from on-premises, so they're bringing their data to Azure's data lake, which is the TimeSeries Insights data lake. So being able to do a batch upload, batch ingest is an important scenario for us. Data connectors we talked about. We're taking TimeSeries Insights to the edge, so we will be able to provide, we again have some POCs underway. We're serious about making sure that we provide equivalent capability or similar capability for edge scenarios as well. And security, not the most important piece of this all. We're doing a lot of work to support role-based access control and multi-tenancy and data deletion. So Eustace will talk a lot about security, and I want to hand off to him with a minute or two delay. Sorry about that, Eustace.
No problem. Thank you, Chandrika. My name is Eustace Asangawa, and I'm Program Manager for Security in Azure IoT. So as Chandrika introduced, this section is about security. So when it comes to IoT, security must be end-to-end. So this is not news to you, but give me the chance to explain what it means to us. It means whatever role you play in IoT, you must think about security holistically, security from devices all the way to the cloud, and that is the way we think about it at Microsoft. So one of these ends is about device security, going the right direction. Security on devices. So Microsoft, we offer SDKs in many languages out there where we implement security best practices into it. We offer this for any operating systems that you can use, and we'll give you the freedom to be able to choose any root of trust in order to harden that security. Any root of trust, which may or may not come from Microsoft, this includes Azure Sphere, and the guidance there is that you best know the risk of your deployment, and you can then choose a security root of trust based on that. Then we talk about connectivity. Every connectivity of a device to Azure Cloud is secured over TLS. So this is a very well-matured standard and technology. No need to spend a lot of time there. And then when it comes to cloud, Microsoft does a lot of investments there. So one of them is the services that we implement in the cloud in order to assist device security. So you have services on Azure IoT Hub, you have services on Windows IoT, and you have Azure Sphere services to assist device security. Then on the cloud itself, there is tons of investment that Azure is doing on there. If you search for Azure Trust Center, you see a lot of this investment there. And one objective measure of this is the number of Azure compliance, the number of compliance offerings that Azure offer. So this is, Microsoft offers the most compliance for any cloud provider in the world. And it's one way to know how much investment Microsoft is doing, because this is an objective way, a transparent way of knowing the true investments in the cloud. So as a platform, we offer a platform that you can secure your devices on there. Our goal really is to have you forget about security for us to do it all. But then there are certain things that really need your input there. But not to worry, we offer the tools to do that. So one of those is about provisioning your devices. So when it comes to provisioning, only you know how your devices would manifest in your deployment, where they are manufactured, where they are going to be sold, how many custodians the device is going to change in its lifetime, where they are retired. And the one thing you don't want to worry about when you're provisioning your device is about moving identities from here and there. What we offer you is device provisioning service, which is a cloud control point, a central point from the cloud where you can control all your devices, control the provisioning of your devices. So we give you that as a tool. And once you provision the devices and you have your IoT deployment up and running, the next thing that is important is understanding the security posture of your IoT deployment at any time. And with this, we offer Azure Security Center for IoT. So this gives you the ability to monitor not only the security of the devices, but the entire application. From devices, the cloud applications, the operation of those applications, the connectivity, where are they coming from, and even the administration of it, including the admins of the cloud, of the IoT deployment. So if there's any anomalous behavior, Azure IoT Security Center is there for you to notify you through alerts, and it gives you suggestions on how you can go about remediating those alerts. So we'll build this and we'll capture a lot of the common security practices, the things that you need to be watching for, but we'll also build it to be extensible so that you can add specific scenarios that are specific to your deployment. So a platform for security, an ability for you to provision your devices at scale globally, and a way to monitor your deployment, the security of your deployment. So that gives you very good security today. But moving forward, if there's anything that you got from this presentation from Olivier and Chandrika, it's more than the devices. It's more than the telemetry. It's more than the data. It's about insights, and having these insights generate valuable actions. When it comes to this, the insights we are more and more depending on machines to be able to gather telemetry, generate actions to control infrastructure downstream, sometimes critical infrastructure. So in a power generation scenario, for example, it is not enough to gather information or to base on historical usage in order to turn on generators downstream. You need to be able to manage how you turn on generators and turn those off real time, based on real-time consumptions. And if we have this kind of compute, these kinds of insights, directly generating actions that control critical infrastructure down the stream or downstream, the one thing that you start worrying about is who else has access into that compute environment for those insights. And what can they do if they get access into it? So for that, we've been investing in confidential compute for the purpose of protecting these kinds of insights, or even more abstractly, offer a safe environment for which to carry out certain kinds of compute. So what is confidential computing? It's about using special hardware called Trusted Execution Environment, or enclaves, that gives you a safe isolation, a firewall around an enclosure where you can run sensitive workloads, where you can manipulate data that is sensitive so that nobody else can gain access into it. So with enclaves, data, workloads, the sensitive workloads exist encrypted everywhere else except inside of the workloads. Authentication or access into this environment is authenticated so that only the right personnel or the right actions can gain access into it. And have policies that you can layer on it on how the compute inside of this environment, how the compute would work. So to show how serious this is, this isolation even distrusts an operating systems, because sometimes operating systems are vulnerable to zero-day attacks. So it's truly a hardware isolation down at that level. Some of the prominent technologies of trusted execution environment is trust zone technology from ARM, and also software guard extension, XGX, from Intel. So this concept of trusted execution environment is not new, but it's been localized in very niche industries like banking, like government. And the reason why it hasn't spread out is because it's very, very difficult to develop in this environment. If you imagine environments where you get no visibility into it, and you're using this environment for the most critical of workloads, you can see that without ability to debug, without ability to write software and gain visibility into it, it becomes very difficult to develop in there, which is the task that Microsoft undertook in order to simplify this in IoT. And the way we did this is through Open Enclave SDK, which is an SDK abstraction over enclaves and a consistent API across different enclaves technologies. So our goal here is to use the same enclave API and technologies and deliver confidential computing, whether it's at the edge or in the cloud itself. So Open Enclave is in public preview. Open Enclave SDK is in public preview today, but we are already getting accolades in the industry. So with alignment with some of our partners, Scalise being the forefront in putting what we call TrustBox, which is an industrial-grade IoT. Industrial-grade, meaning that you can use the same box from your pilot and go into your pre-production. So with Scalise, and using technologies like Open Enclave and Azure IoT Edge from Microsoft, and also Trust Zone technology from ARM, and a SOC from Layerscape implementing the Trust Zone technology, we put together a solution that won the Best of Innovation Awards in security and privacy at CES 2019. So this is a technology which is still in public preview, but we are already winning awards on there. So I'm going to switch now into demos, but you have some links there. I'm going to switch screens to go into demos, but you have some links there that will come back to you. But before I go there, let me introduce the demos first. Let me introduce the demos, because I'm going to go to a different screen. So we're going to do a demo here. It's about machine learning confidential compute. Okay, so when it comes to machine learning and AI, that is some of the areas where we have intellectual property in there, assets that you want to protect. So in this particular example, we will be doing confidential inferencing of handwritten digits. So think of this as you have your AI model, which is valuable to you, and you want to protect it. You don't want anybody to gain access into it. So I will show a series of demos here, time permitting. And this is going to build around Open Enclave, how it is enabling this confidential compute area. The first demo is going to use IoT Central, our SaaS application on IoT, so the highest level of abstraction. Here, we're going to use it to access confidential compute inside of a trust zone technology inside TrustBox. Then the next one is going to showcase the use of confidential computing with Azure Confidential Compute. So inside of Azure data centers today, we already have hardware, trusted execution, hardware that offers trusted execution environment, and also service Azure Confidential Computing that allows you to access confidential computing inside of the cloud. And finally, I'm going to show some demos about developer experience, how we really aim at simplifying this. So these 3 demos I'm going to try to show, and I think we have enough time to do those. So switch now to 7. Refresh, yeah. So in front of me here, I have a TrustBox device. So this is TrustBox over here, industrial grade device, okay? I have one of the devices in front of me, and on the screen here is IoT Central on there. So over here, the idea is you are developing in IoT Central, and you have these machine learning models that has been encrypted everywhere else, but loaded into Trust Zone, and in there you can use it inside of Trust Zone and do inferencing there securely. So what you are looking at here are a series of samples. The first sample is going to send a handwritten number 2. The second one is going to send a handwritten number 1, and then the third one is going to send 9. We may not have time to run all of them, but we'll get the idea here. So sending the first sample, and it's sent, and it's going to take a minute or 2 for it to come up here. And while that is happening, I'll go ahead and send the second sample. So what is it we're doing here? There is an image file, an image capture of a file of a handwritten number. Our goal here is to be able to have machine learning detect this, but does so inside of an enclave. You just send the next one. Now go to measurements. So over here we have 2 feedback from it. So the first one detected the number 2. The second one detected the number 0. And the third one, 9. So 209, which is 209, which is what we expected. Okay? Then now I'm going to switch this and run the same demonstration using Azure Confidential Compute VMs inside of the cloud. So one thing I need to do is to log into a VM enclave. Typing here. Okay, we're in. So what I want to do here is to start an SGX enclave inside of ACC, Azure Confidential Computing. I'll start a server there. And while that is starting, I'm going to launch a client from which I'm going to be running the commands from there. So log into client. Okay. As soon as I log into the client, I will let me try to zoom. It may take a while to get there, but let me see. We might be able to make sense of the result. So what I'm going to do here is to send an image file into the XGX enclave. The image file that I think is a handwritten 2. So that's the ASCII capture of the image, and it inferenced it and recognized 2. Can we see this 2? I'm trying to zoom in here. What's that? That's better. So that's a 2. Yep.
Get out there.
What's that? Thank you, Olivier. Thank you, Olivier. We'll get the idea there. So in here, we can do the 9. Send the 9 image file for inferencing. It came up with a 9. Trust me, it's a 9 up there. And so on, whatever number on there. So I'll just try a third number here. An image of a handwritten 5. And it detected a 5. So that is showing that with Open Enclave, using the same workloads, we can get the same results from trust zone inside of a device at the edge, and also SGX hardware technology in Azure. In Azure, okay. And now the third demonstration is about the developer experience. So for this, let's see. A virtual machine disconnected. Get back into it. It's loading. So for the tooling, our goal here is to maintain the same tools that developers are familiar with, Visual Studio and Visual Studio Code, in order to deliver the developer experience. So what I'm launching here is Visual Studio Code. We may not have time for more than this, but we're launching a Visual Studio Code here. Then we're going to load an extension for it. The extension for Open Enclave. And in here, I'm going to create an Open Enclave project. Okay. Select folder for the project. Choose the project type. Call the project Open Enclave. So what I'm going to do before I walk through the source code, I'm going to start the build in the background and take advantage of time there. And inside of the build, you see you have different architectures here, ARM64 and ARM32 up there. So this is going to be building in the background while I go in and show a few things on the source code. So in the source code, you have Open Enclave SDK here. Uh-oh. Let's see how resilient it is. The build environment, the dev kit. But what I want to pull your attention to are these 2 folders here. So there's a host for the regular application, normal world application, and enclave for the trusted application that is going to be running in SGX or trust zone. So in the main file in here, on the main file, what you see here is some function wrappers, and I'll pull your attention to a few. So here you have an open enclave to create an enclave, call enclave to call into an enclave, and also closing it. So let's look at the implementation of this, and I'm not going to go into too deep into it, just for the sake of time. So for the open enclave, what you see here is that it goes in and it decides whether it's an SGX or trust zone enclave. So what we're saying here is that for the developer, you only need to call one function. And this function is going to go in and create the right environment depending on the trusted application, the technology behind the trusted application, whether it's SGX or trust zone. And for anybody who has developed in this environment, they would have noticed that in order to create an application that transfers calls between a normal world and a secure world and vice versa without leaking information or corrupting data, this is extremely difficult and very involving. We are trying to simplify this to bring that world into our normal, traditional development environment. One more thing. So on the debug, I promise to show you the debug, please. Just the debug. So terminal. Looks like it's still building.
Yeah.
Because of the earlier crash, I don't think we recovered.
Yeah, I think
that.
we're gonna cut it short because they only
Yes.
have other sessions 1 to 10 now.
Correct. But anyhow, it would have been the same step in, step out, run, breakpoint, the same debug experience on there had this gone through. So
Thanks.
thank you very much. Yes.
You can blame me for like eating 3 minutes at the beginning. Thank you, guys. We have other sessions. We realized there was a lot of content in that one session, so we'll be at the booth to answer your question, follow-up questions. We'll be at the booth all day long tomorrow. You have other sessions. These sessions are recorded, so after the event, if you miss some, you can actually go back and watch them. Thanks for attending. You can go to MS Learn for learning more. And then you can also answer the survey to tell us how we did. And obviously give us good grades. But in general, we want your feedback, positive or negative, jokes aside, so that we make better next time. Thanks a lot. Hope you enjoyed Build.